everyone. Today we're going to continue on and we're going to learn about the electrolytic properties that happen in aqueous solutions. So, as an introduction, at a young age, we learn not to bring electrical devices into the bathtub, so not to electrocute ourselves. However, pure water is actually considered a poor conductor of electricity. So, what actually makes bath water so conductive that you can't take electronics into the bathtub? Well, the conductivity of bath water actually comes from the substances that are dissolved in the water, not the water itself. Because if we're thinking of water, it is H2O. Unfortunately, water we get from the tap is not pure H2O. It has things in it, such as any of the metals from the earth, such as iron or manganese, but it also has things added to it from the city, like fluoride. So, what does conductivity mean? Well, we can use something called a conductivity meter to figure out the conductivity or the current or flow of electrical particles. We do this by inserting that meter into an aqueous solution, and the bulb is going to light up that shows if a current is being created. And that's because there is a flow of these electrical particles between the two electrodes in the solution. Now, one thing to note is conductivity occurs when ions are present in a solution. And this is the key word is ions because these ions are the ones that carry electrical charges. So we're going to learn two terms here. We're going to learn something called an electrolyte, which is important to know, and a non-electrolyte, which is also another important definition. An electrolyte is anything whose aqueous solution, which means it has to be dissolved, it carries electrons. For example, salt. When salt is put into water to make an aqueous solution, it divides into the ions Na plus 1 and Cl negative 1. A non-electrolyte, on the other hand, is whenever we dissolve it in water, it does not split to form ions. And these are things that are going to be a lot of molecular compounds like sugar. Like we said, not all substances that dissolve in water are going to result in a conductive solution. Dissolving salt versus table sugar, like we showed on the previous slide. So even though both of these are soluble in water, they're able to dissolve in water. One is a good conductor and the other one is not a conductor. So that means electrolytic properties is not the same thing as being soluble. So make sure you guys don't confuse those two definitions. So let's talk about electrolytes. There is an extent to which electrolytes can conduct electricity. We have something called strong electrolytes that create a higher voltage of electricity, and then we have those that are weak electrolytes. Strong electrolytes, these solutes exist in solution completely or nearly completely as ions. This means if you see something like salt, it's going to completely split into Na plus ions and Cl minus 1 ions. You're not going to find whole solutions of salt in the water. Typically, things that are strong electrolytes are things that are ionic compounds because they are made up of ions, and also strong acids and strong bases. So I took this out of the textbook that I teach you out of. Strong electrolytes, all ionic compounds are going to be considered strong. And then for molecular compounds, these are going to include some strong acids. Now, what exactly are strong acids? This is a table that is also taken out of the textbook that I teach you out of, and I would highly suggest you write down these strong acids. They are hydrochloric acid, hydrobromic acid, hydroiodic acid, chloric, perchloric, nitric, and sulfuric acid. These are our 7 strong acids. Strong bases also make strong electrolytes, so any group 1A metal, so 1A are things like lithium, sodium, potassium, rubidium, and cesium. If they are combined with hydroxide, this makes them a base. Also, heavy group 2A metals, which means heavy means they're located further down in their group. Things like calcium, strontium, and barium are going to also be strong bases as well. On the other hand, we have something known as weak electrolytes. This is where when they dissolve in solutions, they're not going to dissolve and form only ions. Most of their forms are neutral molecules, and only a small fraction of them form ions. So, what exactly is a weak electrolyte? This is going to include weak acids and bases. For example, acetic acid. We know acetic acid, most of the solute is present as um, acetic molecules, but a small fraction of them do dissociate into H plus ions, and then these are acetate ions. So on this chart for a weak electrolyte, you're going to see that any weak acids and weak bases are going to count as being a weak electrolyte. So how do we identify between strong and weak electrolytes? And we're also going to conclude if something is a non-electrolyte. Remember, a non-electrolyte means it doesn't have any ions in solution. If we can remember the common strong acids and bases that I put a chart on for, and remember that NH3 is a weak base, we can make reasonable predictions about how electrolytic a solution is going to be. So we're going to classify things as a strong electrolyte, weak electrolyte, or a non-electrolyte. And these are a series of questions you need to ask yourself. Again, I would write down these steps. You should read them in order. So first you have to ask yourself, is the substance ionic or molecular? So ionic is metal and a non-metal. And then molecular, these are going to be all nonmetals, or you could say metalloids. If you answered that yes, it is ionic, we can automatically classify that as a strong electrolyte. If for some reason you said it's molecular, you need to then ask yourself, is it an acid or a base? So remember, acids usually start with H and bases usually end in OH. If you said that it was not an acid or a base, it's usually going to be a non-electrolyte. But be careful when you're determining if it's an acid or a base. Alcohols are actually considered non-electrolytes, and oftentimes people think alcohols are bases because they have a hydroxyl group on them, an OH. But a base is usually going to be attached to a metal. So this is not considered a base because of my CH are nonmetals. This is not considered a base because CH are nonmetals. If you see a lot of carbons, hydrogens, and then it ends in an OH group, these are called alcohols. And usually their name ends in OL. So methanol, ethanol, propanol, these are all alcohols and they're always going to be non-electrolytes. If you said it was an acid or a base, you have to determine if it's a strong acid or base. If it's a strong acid or base, it's going to be a strong electrolyte. But if it's not on that strong acid list or base list, it's going to be a weak electrolyte. So you can go through these series of steps to determine how to classify it. Let's actually do a couple practices with this. We're going to look at the following molecules and we're going to classify them as strong, weak, or non-electrolyte. So let's start with calcium chloride. The first question you should ask yourself, is it ionic or molecular? And you should automatically realize that this is ionic because calcium is a metal. And remember, if it's ionic, they're always going to be considered strong electrolytes. And we can look back on my thing. If it's ionic, it's a strong electrolyte. On the next one, we can look at this and we can say, okay, this is technically considered molecular because these are all nonmetals. So then you have to go on to the next question. Oops. The next question says, ask if it's an acid or a base. And if I look at the following molecule, we're going to see that it starts with H, so I know it's an acid. Then I go on to question 3. Is it a strong acid or base? So let's see if it's on my strong acid or base list. Here I see that HNO3 is a strong acid. So since HNO3 is a strong acid, it's going to be a strong electrolyte. Here we have C2H5OH. We have to ask ourselves, is this ionic or molecular? We're going to see that this is molecular. So we know that it's not right off the bat a strong electrolyte. But we then have to ask ourselves, is it an acid or a base? I gave you a hint, it's not a base. And remember what I told you, carbon and hydrogen with an OH group is not going to be a base. These are alcohols. They end in OLs. So if we look back at our chart, alcohols are non-electrolytes. So we can immediately classify this as a non-electrolyte. On our next one, this one we can look at, okay, is it ionic or molecular? These are all non-metals, so we can say that this is molecular. And then we have to ask ourselves, is it an acid or a base? Here, the name gives it away that it's an acid, but also it has a hydrogen group on here. So we have to see, is it part of one of our strong acids? If you go up, it is not one of our strong acids. So this tells me it's going to be a weak acid. So therefore, it is a weak electrolyte. And the last one, KOH. Here, we have to ask ourselves, ionic or molecular? It's automatically ionic because potassium is a metal. And remember, ionic compounds are going to be strong electrolytes. Now you're going to test if a solution has electrolytic properties and if it's strong or weak in lab. So in lab, you're going to see and use a conductivity meter. This is the conductivity meter we get through Flynn Scientific. The way you test if something is electrolyte is first you have to make sure that the substances are dissolved in water. If they are not dissolved, they're not going to test as an electrolyte. So keyword has to be dissolved. Second, you need to make sure that you have a battery source and a bulb that lights up that shows you if it's conductive or not. Then you're going to put the wires in the solution. So down here, these are 2 wire probes that extend into the solution. And if the bulb lights up, that means that this solution is electrolytic, which means there is ions flowing between these 2 probes that allows a current to happen to light up these light bulbs up here. Now, the brighter the bulb, the stronger the electrolytic properties, or the stronger an electrolyte they are. So I have 2 bulbs, a red one and a green one. If the red one only lights up, it's medium. If both light up, it's pretty strong electrolyte. If neither one lights up, it's not going to be as strong of an electrolyte. So this is what we're going to be doing tomorrow in class. Last thing, we do not want to confuse solubility with electrolyte strength. So for example, acetic acid is actually really soluble in water, but since it's a weak acid, it's considered a weak electrolyte. On the other hand, calcium hydroxide, it's not very soluble in water. It is, but it's not very soluble. But the amount that does dissolve dissociates completely into ions, and that makes it a strong electrolyte. So electrolyte and solubility do not have basically that big of a connection. Don't confuse them. And that's the end of today's lesson. If you have any questions, please make sure you ask. And otherwise I hope you guys have a great day.